This is Chapter 17, Energy Notes. This is the non-renewables that we're looking at. So to start, they go back to basic energy. So, potential and kinetic, make sure you write it down. Kinetic is due to motion. Potential is the object's position in space that will have motion if given. Make sure you write these down. Moving on. Yes, nice vocab words. You need these for the lab. If you're doing these before we do the energy transfer lab, you will thank me later. It'll be a whole lot easier. So mechanical energy is the actual movement of an object, movement of something. So you can actually see it moving across the screen, like my pen would be moving across the screen, type of thing. Electrical, that's going to be the electrons moving across a wire to give us some sort of power of some kind. Thermal is the heat energy, so you're going to feel something. Exothermic, okay, if I can get the pen to work. Exothermic is that you can feel the heat. The heat, come on, Mueller. Endothermic is that it's inside and it'll usually be cold. Light energy is when it's a form of energy that gives us light, like the lights in a room or the sunlight, or like a firecracker. Sound energy is something that gives us sound, so when we snap our fingers or something falls on the ground, it breaks the sound barrier and gives us sound. I'm going to move on, pause this. Forms of energy, there's two more. There's electromagnetic, so this being the waves that are formed, so like a compass. There's the chemical energy, so in our food, for example. And then nuclear energy is the forces of atoms. When we smash them together, they can create heat, which can heat water to produce steam to turn a turbine to power a generator. You'll get sick of me saying that. All right, moving on. Energy conversion and efficiency, you have to remember the law of thermodynamics. Energy cannot be created nor destroyed. It can only be converted from one form into another. In many cases, when it's converted from one form to another, it's converted from one form into many other forms. So, for example, firecracker, that energy is being transformed to sound, heat, and light. Energy efficiency is an expression of how much energy is put into the system versus how much work it actually ends up doing. So when we're looking at a solar power, we know how much work is in there, but we don't know how much it's giving us. A couple energy sources. Again, renewable, non-renewable. Renewable meaning that it will always be there no matter how much we use it or how fast we use it. Non-renewable is that we use it faster than it can be replaced. So for example, water in California is now becoming non-renewable because we're using it faster than it can be replaced. General examples for that are coal, oil, and gas. So the four uses for energy, there's the industrial side of it, transportation, residential, and commercial. You need to know what types of energy go with each of these. What powers the industry, what powers residential, what powers commercial. And we'll get into that a little later. Moving on. All right, looking at fossil fuels. Fossil fuels are coal, oil, and natural gas. I will drill that into your brains. There are three fossil fuels: coal, oil, and natural gas. That will be definitely on your test and your quiz. It's a big thing. We're going to go over each of those, including nuclear. Coal is from power plants where we burn it to heat water, to produce steam, to turn a turbine that powers a generator that produces electricity onto the electric grid. Compared to other fossil fuels, it's cheap. It needs little processing, and it's easy to transport. It is very dirty. It creates a lot of carbon dioxide. It creates a lot of deaths. Trying to mine it out because of how deep it is and how we have to destroy the environment to be able to get it. Moving on. So there's different types of strip mining. They just show you the mountaintop type removal and subsurface. opposing views on this. The mountaintop removal, it's safer for miners, but it's worse for the environment. Subsurface mining, it's more dangerous. It's a little better on the environment, but I mean, you're still digging holes. This can cause shafts to fall and earthquakes and things like that. So it's not necessarily that efficient. If you've ever played Minecraft, you know that subsurface mining can be very dangerous when you run into volcanoes. You really got to watch out for that magma. It'll get you. Oil, it's formed the ancient marine organisms, so it's found underground, usually at the bottom of oceans. We've gone over that a little bit. It's used for transportation. This is where it goes back to that other slide. So transportation is where we use oil. It's also known as petroleum. That's why British Petroleum, BP, British Oil. Get it? All right, moving on. Drilling for oil, there's the primary and the secondary. Basically, it's still a pump. One is where it's coming out of the well by its own pressure. The other is where we force pressure. So primary, secondary, it's all about pressure. All about it. Natural gas, found above or below oil and coal deposits, so you can't have one without the other. It's a lot less polluting. It gives us more energy. It's used for heating appliances. I know I have gas at my house. This is where the fracking comes in. All right, moving on. Make sure you write this down. So when it comes to fossil fuels, we're still using a lot of them. Remember, fossil fuel, coal, oil, gas, they're all used to burn, to produce steam, to turn a turbine to power a generator. So we burn all of these to boil water. Boiling that water gives us steam. That steam can turn a turbine to power a generator to give us electricity. I will say that so many times, you'll get sick of it. So when we're looking at it, a lot of it's going to have to be underground. We're going to have to destroy part of the environment in order to get it, because this is our energy. We're going to look at a lot of different things that are going to debate this and going to show how we can change over energies and what different type of energies are. So some of these major consequences. They release a lot of carbon dioxide. It contributes to global climate change. Please remember that it's global climate change. It's not global warming, because there's certain areas of the world when climate change occurs, it'll actually get colder, like London. London's warm temperature is attributed to the stream of water in the ocean that goes by it. It's warm water, so it actually heats the earth. It actually heats that part of London. If we have climate change up in the North Pole, it's going to make those oceans colder, which will make London colder. So it's global climate change, where one area is not normal like the other. Kind of like how we've been having really, really cold winters. That's not normal. Coal-fired power plants use mercury. That's the other bad thing. It's the amount of mercury that's being put into the atmosphere. We also looked at PCBs a little bit, and that's not helping either. All right, so looking at different well explosions, we talked about this a little bit, so I just want to make sure I mention it again because it's going to be on the final. We've got Deepwater Horizon, where that was that big spill. The different things that they tried to control it, and none of it really worked very well. Okay, moving on. Damages caused by mining. So we're looking at mining. A risk of lives, huge respiratory issues. Black lung disease is from mining. Habitat destruction. Oh my gosh. Okay, there we go. Erosion, acid rain, heavy metal contamination, especially downstream. It produces the runoff. With oil and gas, you have habitats and ecosystems harmed, long-term consequences, especially with, like, now we're seeing that earthquakes are a problem, that there's sinkholes. So when they say long-term problems, it means they don't really know, but they know it's bad. All right. Just like we did last semester, we know that we cannot survive on our own. We need other countries' help because none of this is evenly distributed. So we need to trade with other nations so that we can all be able to survive. That's why renewable resources are so favorable, because that means more independence from those nations. We like to conserve energy. It's a good thing. This type of bulb, fluorescent, is awesome. We did a lab in AP where we tested the efficiency of it. On the box, they tell you the efficiency. It's a little off. It might be upper or lower, depending on how they manufactured and what lamp you put it into and how often you end up using it. But they can last you a couple of years without having to replace them, which is really nice. All right, nuclear power. Simpsons theme song. Okay, so fission, make sure you write this down, nuclear fission. This is when you split the atoms into smaller nuclei. It releases other neutrons and large amounts of energy. So I want you to make sure you write this down. You take uranium-325, you take a neutron, you smash them together. You create 2 daughter cells and 3 neutrons. So there's 2 daughters, 3 neutrons. So if I'm writing this like an equation, trying to figure out what I'm writing, I'm going to put it up here. I'm going to go neutron plus uranium equals 2 daughter and 3 neutron. Because each of those daughters shed a neutron as they go, which means that it's exponential growth. So those 3 other neutrons will hit 3 other uraniums, and it'll keep splitting and splitting and splitting. That's why we put control rods in it, so the control rods absorb some of those neutrons so it doesn't explode. All right, moving on. Make sure you write down the reaction too. All right, so this is generally what it looks like. Yeah, it's crazy confusing. Basically, we're firing the neutrons to produce heat, to boil water, to produce steam, to turn a turbine, to power a generator that produces electricity. There's also a cooling tower so that the water doesn't get crazy hot. So, we are making heat to boil, to produce steam, to turn a turbine, to power a generator, to produce electricity. That's what every single source of energy does except solar. Okay, benefits to nuclear power. Yes, I want you to write this down. There's no air pollution. It requires very little fuel to start and very little mining. Under normal conditions, it's actually safer for the workers. Costs, it's very expensive. Accidents are not little. They're major. Fukushima was one where an earthquake happened that damaged some of the outlying walls, and then a tsunami came that was an effect from the earthquake, and that ended up drowning the nuclear power plant and exploded. And then you have all the other nuclear explosions that have happened from just people errors as well. So you can't have errors with a nuclear power plant. All right, make sure you write this down. I'm moving on. Nuclear waste, it's a problem. We can't do much about it because it takes so long to decompose. And it's very, very toxic. So we actually hollowed out a mountain, Yucca Mountain in Nevada, and we're just storing it there, just letting it chill. You can see, though, in 2010, they're not doing anything else about it because they realize this is not a solution. It's just a big old Band-Aid that's going to burst open. All right, fusion, nuclear fusion, when we're fusing things together, 2 atoms coming together. Currently, it's not very awesome to do because it uses way too much energy, high temperatures, and a vast amount of space. So it's not really efficient, but at some point, we're not going to have a choice anymore. We'll have to do it. Okay, that's it. Yay, smiley face. Oh, I can't draw. Alright. So the test for this is going to be, I'm looking at my list, April 21st. Yep, test is April 21st. So 4/21. Thank you for listening. Have a good day. Make sure you turn these in.